Welcome back. In this video, I'm doing Leetcode problem 719. Find the kth smallest pair distance. It's a Leetcode hard. Yesterday it was daily question, but I haven't had enough time to film the video. And yeah, let's begin. So the distance of a pair of integers a and b is defined as the absolute difference between a and b. Given an integer array nums and an integer k, return the kth smallest distance among all the pairs. Okay, and we have like ij between length. Here we have 1, 3, 1, so 1 and 3, 1 and 1, 3 and 1, and first smallest distance of a pair is 0. Okay, constraints. So n num length, so number of n is between 2 and 10 to the power of 4. Nums of I is 10 to the power of 6 at most and at least 0. And k is surely in the k exists, like that's for sure. So there is a brute force approach that seems straightforward. So just to find all the pairs, so we go 1 first element, then see 3 and 1. Then we go to the second element, 3 and 1, and that's it. And then we would get the distances between them, so absolute difference. And then we would sort them and give the k, but this would be so n to the square. It would be pretty time consuming. The time complexity would be, I think, just for sorting that part would be n squared log n squared. So I think that solution gives time limit exceeded. So I'll go with a different idea. So it's hinted here in a hint. Binary search for the answer. How can you check how many pairs have distances less than x? So let's imagine we get like an array of 10 numbers. And how would we check how to check how many pairs are less than have like distance less than something. So first we need to find how many pairs so first we need an efficient way. Let's say like this. We need first efficient way to find distances between the pairs, and the efficient way is because if it's unsorted, we don't know. Maybe it's like here 1, 3, 1, 5,000, 5,000, 5,000 till the end. So here we have like a lot of numbers, but easy way to do it is to sort the numbers first. So first we would sort the numbers. Let's say after the sorting we have something like this. So 1, 4, 9, 50, 51, 51, 52, 53, 54, 54. So this is our array. And so we already know what's the maximum distance and what's the we know the maximum distance, so it is the maximum number minus minimum number. So 54 minus 51 minus 1. That's the greatest distance between the two pairs. So let's have 55 here just have it easier. So 55 minus 1, that's 54. And to implement binary search, we would take so 27, that's 55 minus 1 divided by 2, so 54 divided by 2, and we would check how many elements there is that have distance less than 27. And that we can do with just a sliding window. So we take 1 and 4. So this sliding window is just to find those pairs efficiently. So we have like left and right. Left is 1, right is 4. If it's less than 27, then we just increase right and add this pair. Here it's also satisfied, so we actually give the distance between left and right. So in this case, we can make 2 pairs out of these numbers. So 1 and 4 and 4 and 9. 4 and 9, and so first we have 1 and 4, and we're ready. So if it's good, we put it, let's go to the result, to the count. When we add +1, then we have now 9, and now we have combination 1 and 4 and 1 and 9, 4 and 9 and 1 and 9. So that's the idea. If the number is okay, we just less than our current like limit, then we just increase right pointer and append and add to the count how many elements have a distance smaller than so 27 in this case. And if it's greater than 27, then we need to increase our left pointer. So when we come here, we'll have one left will be 1, right will be 50. So we'll have to increase left to the 4, right stays at the 50, left to the 9, right stays at the 50. And here again, we'll increase left to get both them on the 50, but since they're both both pointing to the same index, we would increase right here. And then again do that, and then we count. When our count exceeds x, then we need to update our left and right. How do you call it? We need to update the range we are searching it from. So original range was between 0 and 54. And next range will be between 0 and 27. So if it's greater and if it's smaller, then we'll have to increase between, if they are less than 27, then we would search for the number between 27 and 54 and so on. So yeah, I think I gave my best shot to explain this, so I hope it's somewhat clear what I'm doing. I'm starting to code. So first I'm going to sort the elements to get something in this order. I want to find how much elements I have, so len of nums. And so let's have left be 0. So that's the smallest distance, and right is equal to nums of -1, or maybe better is n -1. Right now n nums n -1 minus nums of 0. Okay, so I have left and right, and now I need to. So we need to test all the time. I'll update these left and right in a little, but let's say so test is div count for distance. Let's call it distance function, which will send. So let's like this. So test will be right minus left divided by 2, like this. and we're gonna see count is equal to, let's call it distances of test dist counter. Okay, let's implement this distance counter. So dist counter of let's call it middle element here. So we need to count how many elements there is, how many pairs satisfy. So are less than mid, their distance. And we need left equal to 0, right equal to 1. And while right is not equal n, yeah, I think it should be good. So if nums of right minus nums of left less than or equal mid, so what do? We need some variable to store return. So output res is equal to 0. We'll increase res plus equal 1, and we increase right by 1. Else, if it's not, so it's too big, we need to update our left pointer. So left plus equal 1. But in a case if left is equal to right, right is plus equal 1. And we're going to continue to check if right is not equal to the n. Okay, I think this should be good. And in the end, we return result. I actually do not need to go over the k. Result is okay. I'm not going also here by 1. I need to add right minus left. So if it's multiple elements, let's say 1 and 9, we need to both add combination 1 and 9 and 4 and 9. So okay, right plus 1. So this part should be okay. So now I'm going to know how many elements, how many pairs I have. And so I'm going to test. So while, let's say, true at the moment, not here, but here. So test is right minus left divided by 2. If we count, and we need to check if count is equal to k, then we need to return test. Okay, so we return test. And if it's not, we need to check if count was if count was greater than it's okay. Then I need to update. So we have too many elements. We need to reduce our right side. So right is equal to mid to test. Left stays the same. Else if count or else if else right is equal to test. Else this means so count is less than k. Then we need to increase. We need to search on the right side. So we need to update left. But if mid element, I think it's test plus one. I'm not sure. Test plus one. If count is equal to k. Or left is equal to right. Left is equal to right. We'll check it. But if left is equal to right, then we surely found it. So if left is equal to right, we return, let's say left. I think this is good. Return -1 if this is not, but yeah, let's try this out. So 131 input is 1, our output is 1. Okay, why did I output 1? So first I was testing left was 0, right was left was 0, yeah, right was so 3 minus 1, 2. Right was 2, so test was 1. 2 minus left divided by 2, that's 1. I counted distances of test. So for the 1, we have left, right, this was 1, and 1, 1, 1, 3. So we have 1, 1, that's distance 0. So this was 1. Right minus left was 1 here. So res was 1. Then we increased res by 1. So this was 1 and 3. Yeah, if it's equal, we're not sure if it's equal, we're not sure actually. So we have 1 exactly that is less than this, but we are not sure if that number exists in um, so how to check if that number exists? Yeah, I need to I must not return when count is equal to k, because that's maybe good threshold. So in this case it was, we have only distances 0 and 2, so we have 0 to 2, and we chose 1, and we found that one element is less than 1. But it's actually also less equals 0. So in this case, we only want to return when left is equal to right. And how to increase left and right? So we're not sure if that's the correct answer. I know it's how would I know if that's correct? Right minus left divided by 2. Well, I can increase left to the test. But do I need to increase? I need to decrease right. That would be, yeah. It is right or it's less than right. So I need to decrease right in this situation. So if I don't return here, if count is greater than k, then right is equal to test. Greater or equal. And I'll remove this. Let's try this out. Okay, seems good for this case. Time exceeded for 161, so we have how many tests I've passed. Oof. This seems pretty bad. Shit. In this case, we have 116. And I want to return 3. So I have 116 here. 116. I will try with 6 minus 1, that's 0, and 5. 5 divided by 2 is 2. So right is 5. 1 and 1, 1 and 6. 1 and 1, 1 and 6, 1 and 6. So 5 should be returned here. Okay, I'll try. Have 116, so right is equal to 5. Test is 5 minus 0, that's 2. 2 divided by 2, that's 2. So count how many of them are less than 2. This case is not good. So how many of them is less than 2? So we have 1 less than 2, we have n is equal to 3, so this will be 1, this will be, I think this messed it up. So 1, so first case is looking at this, that's 1. Then I look at this, that's not less than 2, so I increase left. That's not less than 2, so I increase left. And I have both of them pointing at 6. So if both of them are pointing at the same thing, I increase right and I continue. But right should be equal to let's print here. I think this is not the problem. Print this test for this solution. Yes, I must not continue. I can do if r is equal to n turn res. Let's try now. Time limit exceeds. Okay, now this part is not good. Also, probably wasn't about this. I think we always test this condition. So we had 5 and 0. We tried 2. So count distance counter test of 2. If left is equal to right, and that's not correct, we turn left. Else if count is greater than k. So counter was less than k. Right is test, else left is test plus 1. So now we have 3. We don't have 3. We have left is test plus 1. So the left is 3, right is 5. Yeah, this was also not pretty nice because this is the way we do it. Oh yeah, okay. Yeah, messed this part up because I was I haven't chosen so element between them, but just the was the like half of distance between them. So yeah. Okay. It looks pretty solid for the complexity. So sorting takes n log n. For binary search, it is log n. So we do log n plus this part is, well, r is not equal, and this will be at least. So each time we increase n or l, that will be n, so should be n again if I'm correct. Yeah, should be an again, and we don't have any additional, so space should be of 1, I think, but we have there should be of 1. Maybe I can see if I can analyze complexity, so font size. Let's do it like this. Try new version. Yeah, it's an again. For the space, I think it's of 1. Yeah. Okay, I'm right about this one. I hope it made sense. I tried my best to explain it. Have a great day and see you in the next one.